And welcome everybody to the Daily Space Weather. We've got very low levels of solar activity today, so we'll cover some stuff we don't normally cover here on the Smash News Network Least Busted. Name and news. This is the sun and ionized helium. It's helium that has no electrons. It's highly reactive. As a result, it really wants some electrons. It's 304 angstroms from the Solar Dynamics Observatory. It's great at showing filaments. We do have some activity rising here. We actually saw some solar flares, some minor B-class flares. We'll get to that in a moment. There is also a coronal mass ejection watch in place. I just wanted to briefly show this view here. This is 1600 angstroms, ionized carbon. It's carbon-4, so 3 times ionized carbon. It's missing 3 of its electrons. What's interesting about this, folks, is that it shows us nuclear fusion happening on the surface of the sun. It's showing us the upper photosphere in the transition zone. The reason it's so dark is because of the low levels of activity. When we see higher levels, we'll see brighter regions. And all of these images are showing you high concentrations of a certain chemical in the bright spots and low concentrations in the dark spots. If you want to read more about carbon-4, thrice ionized carbon, it's the 1600 angstroms view. You can go to the SDO The Sun Now page. If you click on these little eyes next to the different wavelengths, it will give you a brief description of what it is. Temperatures here are about 100,000 Kelvin. Here's a colorized magnetogram, and we've brought up the last 5 days to show the degradation of sunspot 2904. It's no longer a sunspot. And there you can see its magnetic fields losing their organization. Looks like another zero sunspot day unless something suddenly appears or rises. There is some activity rising out here once again in the southeast. We'll be keeping an eye on that, and when I say ion, pardon the pun, this is 171 angstroms ionized iron. And this shows you the lower chromosphere. It's also great at showing magnetic looping around sunspots and so forth. The 10.7 centimeter radio flux is the most proportional data set to sunspot number. As the sunspot number comes up, so does the radio flux and vice versa. It's only at 77 at the moment. There's a 1-year chart. The black line is the radio flux. And you can see the sunspot number has fallen off a cliff to 0 the past couple of days. Here's your Space Weather Enthusiast dashboard. No space weather storms in the forecast, although there is some expectation of a filamentary strike. So, I don't know. It doesn't really seem to be showing up in this model. And if you follow us on Twitter or at smashamash.com/smashteam, you would have seen a forecast about this already. You can find links below the video to our own websites. Anyway, that's one of the forecasts from the Space Weather Prediction Center. Let's talk about earthquake droughts. We're still seeing a 7 magnitude earthquake drought despite having one recently. Look at how long the drought was in 2018 and what happened after the drought. A ramp up to an 8+ magnitude and another 7.8. Quite quickly after that, as well as a series of 7s. Earthquake droughts tend to end in large earthquakes. There's a decent drought last year as well between July and November. And you can see there's still an earthquake drought going on at the moment. So this is the 90-day bar graph. You can see only 2 7 magnitude earthquakes in the past 90 days. Which means the planet is due for some large earthquakes. We've been seeing some 5+ magnitude quakes off the coast of Oregon here. The largest being a 5.8. We also saw a 5.4 in the last 24 hours. Let's scroll up the list. Nothing over a 6 magnitude, I think, in the past 24 hours. There's a 5.7 at Papua New Guinea. As the earthquake swarm continues off of the Oregon coast. There you can see a 4.6 and another 4.6. There's a 5.2. And keep in mind, folks, any earthquake can be a foreshock. Never assume that the latest earthquake is all that's happening. Any earthquake can be a foreshock. So anyway, there's a 5.4. About 150 miles off the coast of Oregon there. And if we miss anything, just leave us a comment. Let us know. We consider the videos a collaborative effort. Whether or not they're suppressed from showing up on your feed or not, whether or not they're banned or shadow banned or censored in any way, demonetized, buried in search, etc., we still consider it a collaborative effort, despite the pathetic censorship on platforms like YouTube. Next, volcanoes. Over the past 24 hours, we see La Palma continuing to erupt here in an explosive fashion, producing an 8,000-foot ash plume. Abico on Paramushir Island has been downgraded to alert level green. So all looking clear at Abico. Sakurajima, flight level 070, it's producing a 7,000-foot plume of volcanic ash. And here's a new one on the list, Aoba on the Isle of Vanuatu, showing some unrest there. Elevated activity dominated by steam and gas emissions. Also wet tephra ejected to an approximate height of 10 meters above the lake. So some tephra coming out of the lake. More on that later. Omtok in the Fox portion of the Fox Islands portion of the Aleutians. The deformation has returned to background levels. So it looks like that one might be chilling out as well. The typical sign is near constant inflation. No, not inflation of the US dollar, inflation of the ground around the volcano. Fuego, located in Guatemala, is exploding. 15,000-foot ash plume from Fuego. Sangay in Ecuador, 21,000-foot ash plume from Sangay as it explodes. Revenador, located in the nation of Ecuador, is exploding as well. Flight level 150 there. It's a 15,000-foot ash plume. Sabancaya, unable to detect. Don't assume it's not erupting. Nevados de Chilean, exploding. 13,000-foot ash plume from Nevados de Chilean. Don't pole vault the caldera. Do not pole vault the caldera. And if you're wondering what tephra is fragmental material produced by a volcanic eruption, regardless of composition, fragment size, or emplacement mechanism. In other words, some rock came out of the lake, some volcanic rock. Tephra. There's a term defined for you. Let's continue on to space weather data. Here's the GOES magnetometers over the past 3 days, and a little bit of a divergence there in the readings from the GOES 16 and GOES 17. Keep in mind they are at slightly different locations. And to give you an idea of where they are, they're near the equator. These M's, that's midnight local time for the GOES 16. That's noon local time for the GOES 16. The blue letters are the midnight and noon time for the GOES 17. There could be a North Pole current sheet headed our way. Here's the top view ecliptic plane field plot. We do see some activity in the southeast of the sun that could affect the current sheet. Keep in mind this data is 1 hour and 34 minutes old and can change suddenly. Here's a line of sight view. Also shows you the solar magnetogram. No sunspots is indeed Astoria. Cycle 25 takes its good old time ramping up. Here's a solar polar field progression process in the form of the line of sight coronal hole plot. Really, there's a shortage of coronal holes at the same time as there's a shortage of sunspots. And if you think there's a relationship between the two, let us know in the comments. Hint, there's a relationship between the two. Next, a visualization here. This is extreme UV in the wavelength of 193 angstroms from the SDO. And you can see the coronal holes there. that we showed you on the previous pane. Don't be a previous pane. Let me check the life of the stream here for a quick moment, as this video was originally streamed live to twitch.tv/smashomash, a largely censorship-free platform, much less pathetic than YouTube. Next, the likelihood of flares is actually very low here, although we are seeing some here from behind the limb, it looks like, an indication that there may be a sunspot making its way to the Earth-facing portion of the disk. We brought up the coronal holes imagery today because, well, the sunspot imagery isn't showing any sunspots, so it's outdated. Again, likelihood of flares not all that high, but it is slightly elevated as we see some flaring region rising there in the southeast. By the way, welcome everybody to the Neo-Renaissance. Congratulations on realizing this channel and these videos exist. We endeavor to continue to bring quality content to your screen despite the pathetic censorship of big tech, self-destructing platforms like Facebook, YouTube, Twitter, and so on. So please support the channel by becoming a member of the Smash Team or picking up merch. You can find links to that at the homepage. There's Smash Team, there's Smash O merch. You can also click on this image to go to the Smash Team site. Here's the merch site. Again, you can click right there, and you'll find our merch site. By the way, I don't know if you were aware or not, but Hell has been unanimously voted again, 2 years in a row, as the dimension of the year. So congratulations on everybody who's been making Earth a living hell. We would encourage all of our viewers to make America not suck again, since America leads the way on these sorts of things, in an effort to make Earth not suck again. These are listed in order of best selling. They make great gifts. Perhaps pick up a Fauci Face of Evil bath mat so you can put your feet on the face of evil every time you shower. I would once again remind you, do not pole vault the caldera. If you're going through hell, keep going. That's a Winston Churchill quote for you. Here's a sneak peek of what we've been posting at smashomash.com/smashteam. Did you know that raw data doesn't lie, but climate fraudsters do? Yeah. Now, I've been studying climate since 1987, when I first took Earth Science in 8th grade. And I haven't stopped studying it since. It's a bit frustrating. Let's take a look at the X-ray flux profile. And you can see some minor flaring here. Again, that's coming from behind the limb. Probably a sunspot rising. We'll keep an eye on it, and pardon the pun. No spikes in the proton flux. No major flares. No relativistic particles striking Earth space. Let's take a look at the real-time solar wind. And we saw a mild intensification here. Looks like a bit of a coronal hole wind stream showing up. Current solar wind conditions elevated in terms of the density. 18.55 protons per cubic centimeter is the density. Solar wind speed still very low, 313 kilometers per second. We can expect to see the density drop off and the speed come up. That looks a lot like a coronal hole wind stream signal to me. What about you? Leave us a comment. Let us know what you think. Here's the KP index, a measurement of global geomagnetism over the past 3 days. We've been at a KP1 for the past 9 hours. And the 9 hours before that, KP0. It's geomagnetic calm conditions. Here's the magnetohydrodynamic pressure, modeled by the space weather modeling. Here's me trying to learn to speak English. It's the magnetohydrodynamic pressure, as modeled by the space weather modeling framework over the past 4 hours, if all is going according to plan. So we're seeing pretty homogeneous pressure here, it looks like, over the past 4 hours. There will be an uptick here, I think, when the density increases. And there you can see that little density increase, as we showed you in the real-time solar wind. Next, ground magnetic perturbations. We showed you the Earth's magnetic moment from space. Here's Earth's magnetic moment from the surface. The scale here is nanotesla, and in the previous imagery it was in nanopascals. Nanotesla is magnetic flux density. Nanopascals is magnetohydrodynamic pressure. And you can see a little uptick there on the ground as well, with the increase in the solar wind density. Next, a solar system forecast. We're going to give you the 1 week forecast. By the way, we're only 2 weeks from Christmas Eve. Do you have your Christmas shopping done? We haven't done any. There's where things will be in a week, approaching another full moon. the December full moon, going to fall on the 18th, I believe. Here is a diagram of the sky above my head. Now, I use in-the-sky.org. I face mine to the south. I'm currently facing the south. And indeed, so is my sofa, where I watch these videos. Because one thing you may not realize, folks, is that I'm not only Smash-O-Mash, but I'm also a client. Today, the sun will be passing through Libra and Virgo and Leo and setting in Gemini. It'll be crossing the galactic plane just as it sets here. In the Lehigh Valley, the galactic plane is that blue line you see there, and the yellow line is the ecliptic. Again, there is a coronal mass ejection watch in place, and we'll show you a couple coronagraphs. The left imagery here will be from Lagrange point 5 stereo A. The right imagery will be from Lagrange point 1 LASCO C3. Stereo A coronagraph here on the left, LASCO C3 on the right. Also Mercury showing up there on the imagery as it turns the corner to catch up to Earth in its orbital process. Again, coronal mass ejection watch. And for you new viewers out there, we only forecast coronal mass ejections for this side of the sun, not for this side. Although occasionally we do throw in a far side coronal mass ejection because we're able to forecast them on both sides. Let's do a brief cosmology segment. Today's random number is 492, which coincides with a Seyfert 2 active galactic nucleus, known as NGC 5728. It's an inconsistent X-ray source, as you can see here on the historic graph. Actually, it's showing us 2 daily graphs for some reason. That's kind of weird. But at least in the last 30 days, it's fairly inconsistent. So let's take a look at this one visually. Again, this is number 492 on the transients page at the Neil Gehrels Swift Observatory. And here it is in X-ray from the Chandra. So this gives us insight into the galactic core. You can see what's interesting about this is it's got more concentrated X-ray flux on this side than on this side, giving us some insight into the shape of the galactic core region and so on. Let's take a look at some more imagery here. Let's bring up the UV spectrum. We're going to go to featured CDS feeds. So there it is in ultraviolet. And you can see this is a galaxy that has sort of a ring feature. This may be something in the foreground or background here. I'm not exactly sure on that. But there it is in ultraviolet from the Galix. And here it is on the Pan-STARRS. Great high-res imagery there of New General Catalog 5728, the Seyfert 2 active galactic nucleus. And let's close out this portion of the cosmology segment in infrared. So that could be a background galaxy. It could be a satellite galaxy. It could even be a foreground galaxy or a star, frankly. And here it is on the DSS-2, another great high-resolution image of entry number 492 at the Neil Gehrels Swift-Bat X-ray Observatory, the Seyfert 2 active galactic nucleus NGC 5728. Here's the astronomy picture of the day at apod.nasa.gov. It's the December 4th total solar eclipse from Antarctica. Yes, as summer approaches, the sun will not be setting over Antarctica. And there you can see the moment of totality. If you want to view it yourself, it's at apod.nasa.gov. That's today's cosmology segment integrated into the Daily Space Weather video as incentive for all of you spaced out viewers to watch our daily content. If you want to see some cosmology segments by themselves, check out youtube.com/smashamash/playlists to find over 200 cosmology segments. Let's take a look at charging hazards. There aren't any. By the way, these are the areas where the GOES 16 and 17 are located, near equatorial geosynchronous orbits. Here's the one-year chart of the relativistic electrons as measured by the GOES 16 and 17. And here are the last 3 days of measurements. And the GOES 16 went into warning territory here. The GOES 17 leveled off. You can see that blue line there, just making it above 1,000 particles per negative square centimeter. Here's a relativistic electron forecast model, and I would tend to agree with this as we are seeing the arrival of a coronal hole wind stream. So the forecast model is for a dip. I would agree that green boxes are the forecast. The yellow diamonds are not lucky charms. Those are the observations. Next, we're going to show you the total electron content, which is the electron content between the ground and your geosynchronous satellite. Those are located at about 12,500 miles of altitude. And here's a total electron content forecast. It'll show you where GPS errors are most likely to happen. We are seeing some GPS errors likely over portions of the U.S. there at unexpected times, perhaps a little bit of chaos, and we can expect to see additional anomalies and GPS errors in weird spots. That is a characteristic of the arrival of coronal hole wind streams. We've covered it time and time again on the channel. Depleted electron flux is associated with chaos in the location of concentrations of electrons. Next, another diagram to show you where the F ionosphere layer is. It's at about 300 kilometers of altitude. Feel free to pause the video. If you want to examine that imagery, keep in mind distances are shown there in kilometers. Here is the F ionosphere layer, and it's got some anomalies. More high-frequency anomalies in the southern hemisphere as southern hemispheric summer approaches. And I love the northern hemispheric winter solstice. I like when the sun gets low in the sky. It's kind of cool. And you can see a bunch of low-frequency anomalies showing up here around equatorial Pacific Ocean, as well as over Africa, the Middle East, and lots of North America. Lots of the northern hemisphere in general. In fact, low-frequency anomalies showing up all over the place there. Again, we can expect electron fluxes to decrease quite a bit here, especially when the high-speed portion of the currently striking coronal hole wind stream arrives. Anyway, there's the latest image. There's the ionogram at 1300 universal time. There is the anomalygram, which is showing you anomaly in megahertz from the 30-day median. If you haven't checked out our meteorology segments, check those out. They're quite good, and we are interested in showing people the physics of how things like your weather works. So let's do bonus features. And the first bonus feature we're going to do today is from Cerro Tololo. So let's break that out. And here's the ground-based solar observatory at Cerro Tololo, Chile, part of the National Sunspot Observatory. Keep an eye on this area down here. We can see some flaring already happening. It could be quite a significant sunspot, as we're seeing an uptick in flaring without even having it on the Earth-facing portion of the disk. Coronal mass ejection watch remains in effect, folks. You can see filaments down here, filaments up here. Some of those will eject. Some of those might collapse back onto the solar corona. Who knows? Here is the GOES 16 SUVI current imagery. And you can see some prominences coming up down here in the southeast. 0 sunspots as cycle 25 takes its good old time progressing. Here's the latest intensitygram and colorized magnetogram to show you 0 sunspots. Nothing visible yet there. Do we see magnetic fields making their way up? Nope. No areas of significant magnetic organization. We'll close out today's video with a composite view. This is 171 and 304 angstroms. The red is ionized helium, and the gold is ionized iron. You can see how differently those spectra appear, giving us all kinds of insight into heliophysics by the way different species of ions behave. Anyway, congratulations on realizing the channel exists. Thanks for tuning in, and may that solar wind be at your back. Opinions expressed in this video, not necessarily the opinions of Smash News Network, least busted name in news.